Last class, we went over some basic problem solving tips, setups, so that today you guys could work through these problems. I'll have the answer key uploaded and you guys can just practice it. You can rewind this video, go through it as many times as you need. I'm going to be pretty thorough, so if you need to skip around because I'm going to be kind of repeating myself, feel free. But again, use this as just a tool for you while I am out. So, you are thrown horizontally at 15 meters per second from the top of a cliff 44 meters high. Already set it up with a person getting thrown off the edge. They're going to travel horizontally, and then they're going to, hit the ground with a parachute. That's what that is. Yay, they're fine. All right, they're not dead. So anyway, you are thrown horizontally at 15 meters per second. Horizontally means it is going to be going in the x direction. We are going to refer to the x as the horizontal, just like we've done in the past with graphing, and y is the vertical. Just a quick reminder, y will look like this. That's y. X will look like this. Left to right. Okay, so that's x. That is y. Since this is horizontally, we know that's going to have to be in the x direction, okay? And because it is in meters per second, we know that's going to be our Vx. Something to note about Vx, we know that any object that is traveling in our class, air resistance is going to go ahead and be 0, so we ignore it completely. And that means there's no force to slow it down, so Vx stays constant. Vx does not change. This, if you're going to understand anything about this kind of topic, this is really, really important, and so is this next concept. An object is being thrown horizontally, so it's being launched perfectly horizontal. There is no angle. It's not getting launched up in the air. It doesn't have any angles. We don't have to do any trig. It's just launched perfectly flat. As close to perfect as my drawing could get. What that means is that any object that is launched perfectly horizontally will have the exact same kind of setup as if we were to do a problem where an object is being dropped and then it hits the ground. Okay? It's being dropped. And whenever we have an object that is being dropped, we know its initial velocity is 0, and we also know acceleration is negative 9.8. What that means is a dropped object and a horizontally launched object will both hit the ground at the same time. So we can basically break this up into a free fall problem, where we just drop an object easier than the stuff you're doing where we had initial velocity, or we are looking at the horizontal motion, and we are just looking at a very, very simple V average formula. Okay? So now, VI is 0, so that means VIY is 0. I meant to write this earlier. Please go ahead and write that now if you didn't already. That should be 15. We also know, because it's being launched horizontally, we also know acceleration is negative 9.8. And that's it so far with just that one piece of information saying that we are launched horizontally at 15 meters per second. We can get Vx, we can get Vi, and acceleration. Anytime you see the word horizontally, immediately start thinking of these two scenarios of Vi of 0 and A of negative 9.8. From there, we've got dy. It is 44 meters high. So that means that is going to be in the y direction. Height and high refer to the vertical motion. And because it is falling 44 meters, we're going to go ahead and say that is negative. Now, the trick to these questions is figuring out, do I start with my x side or do I start with my y? In this case, x only has one piece of information, whereas y has quite a few. It has dy, it has viy, and it has ag. I'm going to go ahead and tell you the only times, let me stress that again, the only times that you are ever going to use the horizontal side first to find time is if you're given both of these pieces of information. Otherwise, start with the vertical. Okay? So if we're looking for time first, we're going to go ahead and write out our formula that has time, has AG, dy, and BIY. And to guess what? It's only one formula. It is the displacement formula. Now, when you do these things, don't feel pressured into writing VIY, whatever, all of that. Instead, just write out as normal. Now that we are looking at the Y side, I want you to do this with your hand. I can't visually show this without like scribbling out a ton of information, but pretend you have your hand, cover the horizontal side. You do not need to look at anything on the horizontal. We are now just looking at the blue vertical side, okay? I'm covering it with my hand right now. You cannot see that because I do not have a webcam, and that's not how computers work. So I am going to go ahead and just remind y'all when we're plugging things in, because 15 is on the horizontal side and we're not looking at the horizontal side, do not you dare put that into this equation. You do not need to do that. It's not necessary. It also will cause you to be wrong. Okay? So we're going to go ahead and plug in our numbers. I think these problems are easiest if you plug in numbers first before you do the algebra, but if you would like to do the algebra, you can. Eight times t squared. Oops, forgot the little triangle. Does it matter? No, but I forgot it, so my bad. All right, from here, 0 times t. These cancel out because it is 0. 0 times anything is equal to 0. And I'm going to combine 1/2 and negative 9.8. And I'm going to get negative 4.9 times t squared. From here, the last two steps, because 4.9 is isolated next to t squared, in order to get t squared alone, we got to divide by 4.9 because it is being multiplied. 4.9 times t squared, to cancel it out, we got to divide. All right, and we'll be left with t squared is equal to, give me a sec with the calculator. You would have thought I would have done this beforehand, but it's been a minute. So we get 8.98 is equal to t squared. And if we square root that to cancel out the square, oh, hello, there we go. We are left with t equal to, it's basically 3. Let me see if I want to round it or not. Square root time, 2.99. Oh yeah, let's just make it 3. That makes life easier. 3 seconds. So we're going to go ahead and plug in 3 right here. 3 seconds. From this point, all we have to do is solve for dx now to figure out how far from the base. So this phrasing of how far from the base is always going to be referring to dx. Okay, that's always dx. If you ever see how far from or far, the other word is far away. Okay, that was terrible. That is far. That's the word far. As y'all can obviously see by my beautiful handwriting, that's obviously away. If you ever see the words far from the base or far away from the base or far away from the edge, whatever, that is always referring to dx. Height or the word tall, those are referring to y. Okay, so to just give you guys a hint, how far from the base, that's referring to dx. I'll use this. Far away, I'll make it red because it's horizontal. The words high or the other word tall, or tall, refers to the y direction. So Hopefully that makes more sense. From here, there's only one equation that we can ever use with horizontal, and that is Vx. No, go back. All right. Well, Vx equal to delta dx. Pretend that didn't happen. I'm having to be very careful. We are solving for dx, so we are going to go ahead and plug in our numbers. It's this pair deck thing, by the way, if you're curious why that happened. Pair deck just is glitchy. All right, from here, we have 3 at the bottom. We are solving for dx. So the way to solve for dx, we just got to do opposites. So because it's dx divided by 3, we multiply by 3. Bloop, bloop. Multiply by 3, and we are left with dx is equal to 15. Times 3 is 45. All right. And 45 meters. Will I redo this whole recording again? No, it's too late for that, as you might be able to tell. So, we're going to go ahead and move on. Hopefully that makes sense. That's really it. That's all you have to do for the horizontal side. A lot easier than the vertical. The most errors people are going to have with the vertical side is just people switch whether dx or dy is being talked about, or you just make a minor algebra error. Okay? Don't panic if you do. It's not the end of the world. Just check yourself. Okay? And again, the answer keys will be uploaded. So, that's that. Looking through here, we have some quick tips if we are starting a problem. When solving, just remember that like any projectile problem, you want to use the side with the most given information. You will only ever use the horizontal side if you are given dx and vx. Both of those are needed. So that's 2 pieces needed to solve for t. But the thing that's great about the vertical side is if you're told dy, guess what? Also, VIY and AG are also implicitly told to us because these are always 0 and negative 9.8. Okay? So if you're given just dy, if that is it, and I just realized I switched the colors, but pretend I didn't. If you're ever given just the dy, you can use the vertical side. All right? The key formulas, this is your key formula for the vertical side. This is your key formula for the horizontal side. Again, these two are not technically in your formula sheet, but they are just written as D equals VI times T plus 1/2 AT squared. And this one is V average equal to delta D over T. Okay, now the next one. All right, on to question number 2. Right here we have an object being launched horizontally at 2 meters per second. The word horizontally immediately tells us we got 0 meters per second in our VIY, and we also got negative 9.8 meters per second squared. It's going at 2 meters per second, and that is horizontally. So that's horizontal, so that's left to right. So that means that will have to be our Vx. This problem is a lot closer to what you guys have already seen in the other practice problem with me. So I am quickly going to finish writing these out, and then we're going to talk about it. So from the top of an iceberg, we are 5 meters high. So that means we're going to fall 5 meters. And if we were to draw this out real quick, we got a penguin being launched horizontally at 2 meters per second in the Vx. And then it is all from a place that is 5 meters high. There we go. And the reason I put the negative again is because we are falling downward. Okay, now This question, again, like I was saying, is a lot closer to what you're going to see in the practice problems. There's not going to be a reminder for you to do the in-between step. But the in-between step is always, always, always going to be how long will the penguin be in the air for? You're looking for time first. So again, you'll never see this. The thing that's on the note paper, technically you'll never see this. This is just a little secret that I'm showing you guys as the in-between step. So first we need to find time. We need to find that connection from the vertical to the horizontal. Okay, again, find time. If you don't have time, find time for all of these problems. From here, we have a time. Right now we're missing dx, so we should probably immediately think, okay, let's look over at the vertical side. We've got enough information. We've got all the things to use this equation. All right. So from here, we got -5 is equal to 0 times time plus 1/2 times -9.8 times time squared. From here, we just got to do the math. Start canceling things out. 0 times time becomes -5 is equal to -4.9 times t squared. From here, to cancel out the 4.9, we got to divide it to both sides. All right. And if we do that, it should be, I think, about 1.01. Can I do the mental math? Oh, 1.02. No. Embarrassing. All right. This is 1.02 is equal to t squared. We square root it, and if we square root that, we will get, please tell me it's 1.01. Oh, I remembered something. It is 1.01. Time of 1.01 seconds. Again, whenever you're doing these problems, they're not going to tell you to solve for time, so you need to know to do that immediately without any indicator. Oh my god, that's so annoying. All right, 1.01 seconds. Okay? From here, we are solving for dx. So we're going to do the same thing we did before. We got vx equals dx over t. Because we have the time and we have the velocity, we're going to plug those in. To cancel things out, because dx is being divided by time, we have to multiply by time. That becomes 2.02 meters. That's it. I'm going to go ahead and leave it at that. If you do have any questions, just remember these tips. Look back through the video. Message me on Remind. I can't promise I'll respond immediately, but I'll look at it before the end of the day. Okay? Also, instructions for the day are on Google Classroom. Talk to the sub if you have any questions. And yeah, hope you all have a great day. Hope you enjoy and find time to relax. Cool. Finish the worksheet. Talk to y'all later. Goodbye.